Susan and Bob are paddling on a 20-kilogram canoe. Bob paddles with 50 newtons while Sue paddles with 40 newtons. If the force of friction is 15 newtons, what's the canoe's acceleration, and how long does it take to travel 10 meters if it started from rest? So here we have our diagram. They're going to the right. Force of Bob is 50 newtons to the right. Susan is paddling towards the right as well with 40 newton, and there's a friction force of 50 newtons to the left. And our total mass is 60 plus 70 and plus 20 equals 150 kilograms. So in our net force equation, we always add all the forces together. So F net equals the force of Bob plus the force of Susan plus the force of friction. And F net, now let's substitute some numbers. Force of Bob is 50 newtons. It's to the right, so it's positive. Force of Susan is 40 newtons. It's to the right, so it's also positive. And the force of friction is 15 newtons, but it is to the left, so we put in our negative sign. We add that all up, and that is equal to 75 newtons. Now we can use Newton's second law to determine the acceleration of a canoe. F equals ma, so therefore A equals F over m. Our net force is 75 newtons. Our total mass is 150 kilograms. We do our math and find that the acceleration of the canoe is 0.50 meters per second squared. For the second part of the equation, or the question, we now need to find the time it takes for them to travel 10 meters if they started from rest. Looking at our kinematics formula, we know we'll need to use D equals VIT plus 1/2 AT squared. Because they start from rest, this goes to 0. We need to solve for time. Time is 2D divided by A, square root, equals 2 times 10 meters divided by 0.50 meters per second squared. Don't forget the square root. And our answer is 6.3 seconds. In a vertical example question, we have to include gravity as well. So an elevator is accelerating up at 1 meter per second squared. The table applies a tension force of 1,000 newtons, and we're asked to find the mass of the elevator. So here's our free body diagram. The cable applies a tension force up, Ft, and acting downwards is our force of gravity, Fg. So then in our net force equation, F net equals Ft plus Fg. We can substitute F net with mass times acceleration. The tension, it tells us, is 1,000 newtons plus the force of gravity. We can always substitute the force of gravity with mg. However, in this example, it's actually negative mg because the force of gravity is acting downwards. And we're asked to find the mass of the elevator. Right now, mass is in two places. However, we need to move them to the same side of the equation side. So if we subtract, or if we add mg to both sides, we have ma plus mg equals 1,000 newtons. We can then factor out the m. So m brackets a plus g equals 1,000 newtons. And lastly, we can solve for m. 1,000 newtons divided by a plus g, which is equal to 1,000 newtons divided by 9.81 plus 1.0 meters per second squared. Finally, we figure out that the mass of the elevator is 92.5 kilograms. In this example, you are pushing on a table towards the right, and you're accelerating a table at 1 meter per second, and the table is 10 kilograms. There is a friction force of 20 newtons to the left, and we're actually figuring out what is the applied force that you apply on the table. So here is a real life diagram. and here's a free body diagram. We can see that in our net force equation, we will need to add the force of friction with the applied force. The net force we can always substitute with mass times acceleration. The force of friction, the information tells us, is 20 newtons, but it's acting towards the left, so this is negative 20 newtons. And we're trying to find our applied force, so there's nothing we can substitute for that. Further substitution can be done, and we can also move the 20 newtons over to the left-hand side. So we have 10 kilograms for the mass times an acceleration of 1 meter per second. We're going to add 20 newtons to both sides to move the 20 newtons to the left. And on the right hand side of the equation, we still have the applied force. Now we can do our math, and we know that our applied force is 30 newtons. And because it's positive, we know it's 30 newtons towards the right. The second part of the question asks, what is the force the table applies on you? So the force of the table on you is really the opposite of the force you apply on the table, which we already figured out was 30 newtons. So the force that the table applies on you is negative 30 newtons, which really means 30 newtons to the left.